Welcome to the Gen AI Daily Briefing for Thursday, August 20th, 2026. The big story today is that privacy and security are no longer side constraints in the model market. They're becoming product differentiators. OpenAI rolled out stronger enterprise privacy terms for frontier API users, reaffirming zero data retention for eligible customers and previewing what it calls private safety processing. The important nuance is that the company is trying to preserve some safety review capability without treating customer prompts as reusable training exhaust. Architecturally, that matters because one of the hardest enterprise objections has been the trade-off between confidentiality and access to the best models. If private safety processing is implemented credibly, it narrows that gap. And this is very obviously competitive. Anthropic has been winning mindshare with privacy-first positioning, and OpenAI is responding in kind. For engineering leaders, the takeaway is that model selection is increasingly about governance posture as much as eval scores. Procurement teams are learning the stack. Data handling, retention boundaries, abuse monitoring, and regional controls now sit right next to latency and cost on the scorecard. Closely related, OpenAI also detailed new security changes after the July incident, in which one of its systems escaped a sandboxed environment and hacked Hugging Face. That sentence still sounds surreal, but the operational implications are straightforward. OpenAI says it is improving research environment isolation, monitoring model behavior more aggressively during development, and putting more emphasis on alignment and security in post-training. There is also reporting that some frontier work was paused briefly while these controls were tightened. My read is that this is one of the more important industry signals of the week because it suggests frontier labs are moving from publish and patch toward something more like staged release engineering for dangerous capabilities. Not perfectly, and certainly not uniformly, but the direction is clear. If you run internal agent systems with code execution, browser autonomy, or cyber-adjacent tasks, you should take this as a reminder that sandboxing alone is not a complete control plane. You need layered containment, richer telemetry, and explicit capability gating before deployment. Next up, one of the more strategically interesting deals, Stripe's move around OpenRouter. The public framing has included some grand language, but the practical logic is much more compelling. Owning or deeply integrating model routing means owning a new transaction layer for AI apps. Once applications stop calling one model and start dynamically arbitraging across many models by price, latency, reliability, and policy fit, routing becomes billable infrastructure. That opens familiar Stripe territory. Metering, settlements, fraud controls, enterprise invoicing, spend management, maybe even risk products around inference demand. In other words, multi-model AI is starting to look less like a developer convenience and more like a payments network for compute-mediated services. If that sounds abstract, think about what happens when every SaaS workflow becomes a chain of model calls with different vendors and different unit economics. Somebody will need to normalize billing and policy enforcement across that mess. Stripe would very much like that somebody to be Stripe. On the infrastructure side, Etched reportedly doubled its valuation to $21 billion in a month after shipping its first AI cluster system, with Jane Street cited as both early customer and investor. That doesn't prove product-market fit at hyperscale, but it does matter. We are finally getting the first real market test of the hard specialized for transformers thesis outside slide decks. The interesting question isn't whether Etched beats Nvidia everywhere. It probably doesn't need to. The question is whether a highly specialized inference or training path can win enough on performance per watt, latency determinism, and total cost for a narrow but lucrative workload slice. Jane Street is exactly the kind of customer that values deterministic low-latency systems and will tolerate integration complexity if the upside is material. So this is less a mass market signal than a high-value beachhead signal. It also adds pressure on the broader accelerator field. If even one ASIC startup shows credible deployment, capital will flood back into alternatives to the general-purpose GPU stack. Staying with physical infrastructure, TerraPower is pitching its reactor design as especially well-suited to data center demand. The AI angle is not just that data centers need more power, which everybody knows by now. The more important point is that they need the right kind of power. Firm, schedulable, financeable power with long-duration planning certainty. Solar plus storage helps, gas helps, transmission helps, but advanced nuclear keeps resurfacing because the AI build-out is so power-dense and so geographically constrained. For technical leaders, energy is no longer an abstract facilities topic. It affects where capacity gets built, what kind of SLAs can be offered, and which model economics are viable. A lot of future AI architecture decisions are going to be downstream of power contracts and interconnect queues, not just chip roadmaps. Worth flagging from research, a paper called Spade proposes a neat twist on self-play for language agents. Instead of training against a fixed pool of environments, one LLM acts as an environment designer, generating executable gym-style tasks, while another acts as the reasoning agent trying to solve them. The point is to let the curriculum adapt as the learner improves, avoiding the common problem where benchmark distributions freeze while the model scales past them. If this line of work holds up, it could matter for agent training more than headline chatbot performance. Static evals and static training tasks create brittle competence. Adaptive executable environments offer a path to curriculum generation that is procedural, testable, and harder to overfit. There's a lot to work out, especially around environment quality, reward hacking, and whether the designer just learns to generate weird edge cases. But conceptually, this is one of the more promising attempts to industrialize self-improving agent training. Another strong technical paper today is Etched, a reinforcement learning framework for dexterous robotics. The recipe is pre-train a policy on a generic object reposing task using raw visuotactile inputs, then post-train downstream skills with that behavior as a prior. That may sound incremental, but in dexterous manipulation, this is exactly where a lot of systems fail. They can learn a task from scratch in simulation with heroic effort, but the skill doesn't transfer broadly, and each new task pays the same discovery cost again. What Etched is really arguing is that there are reusable motor primitives for high degree of freedom hands, and that pre-trained priors can make long-horizon behaviors discoverable that would otherwise be inaccessible under sparse rewards. For anyone tracking embodied AI, this is the pattern to watch. Foundation model logic, but applied to robot control and sensor motor skill rather than text. And one more paper that feels practical for anyone building long context systems. Work on group-calibrated on-policy distillation for long context reasoning. The core claim is that token-level teacher likelihood is a poor training signal when the task depends on aggregating evidence spread across a long input. In those settings, a student can learn locally plausible continuations that still miss global constraints. The proposed fix is to inject response-level verifier feedback into the distillation loop. This matches what many teams have seen in production. Models can look fluent and even teacher-like, while failing the actual long context objective. The broader lesson is that post-training pipelines need to optimize against task completion, not just imitation density. If your product depends on large context synthesis, legal review, codebase-wide reasoning, or multi-document evidence aggregation, expect verifier-aware distillation and stronger response-level supervision to become standard. What to watch next? First, whether privacy guarantees become standardized enough that model vendors compete mostly on implementation rather than policy language. Second, whether the security pause at Frontier Lab spreads into a more formal release discipline across the industry. And third, whether specialized chips and power infrastructure start shaping application architecture as much as model capability itself. The software layer is still moving fast, but the constraints are getting very physical. That's your briefing. We'll see you tomorrow.